I'm going to describe several ways that we could solve a nonlinear equation in Excel if we have just one equation. And one way is just to make a plot. So the equation we're going to use is the Peng-Robertson equation of state, where we cannot explicitly solve for volume. And in this case, we're interested in if we have temperature and we have pressure, what is the volume? But we can certainly make a plot by putting in various values for volume and calculating pressure, and then determining a solution for the pressure that we're interested in. The other way is when we have just one equation, we can take advantage of sliders to quickly move through solutions and look for ones that satisfy the equation. And then, of course, the third way is to use the Excel solver, which, of course, becomes perhaps the only solution. We have multiple equations, but here we're just looking at one equation. So let's look at the spreadsheet. So you can see on the right here, list the equations and the parameters. And then here I generated values for volume and pressure. Put in a value for volume, calculate the pressure, and make the plot that you see on the lower left. Second, I've created sliders, which are here. I'll show how you do that. That allow me to quickly vary the volume to minimize the equation. So this equation is just putting everything on the right side of the equation state, everything on the right side, and so that should equal 0. And so we can vary the volume to get that to 0. And then the third way is to vary the volume to get that to 0 using solver. So let's look at the spreadsheet and see how we do each of these things. So here's the spreadsheet, and we're interested in the volume for temperature 250 Kelvin, the pressure 0.093 megapascals. And so if we look at the plot, and what I've done is drawn this green line that's approximately 0.093, and then we can read off. And so we first notice there's three solutions. The lowest volume and the highest volume can correspond to realistic physical volumes. The middle volume has no physical meaning. Which one is the volume for our system depends on the additional criteria that we're not going to worry about here. But we can essentially read off these three values. And here are the values that 41.54, because we can't read that accurately from this plot, but we can approximately read 41 and 120 and 21,000 or so just from the plot. And so that's a quick way. One, making a plot allows us to tell how many solutions exist, and that's valuable information in general. Here we, of course, knowing it's a cubic equation of state, would already know three solutions are possible. And this can be, of course, only applied when we have, perhaps with two equations we can still plot and get solutions, but it becomes less useful. The second way is to use these sliders. So if you're not familiar with sliders, if you go to File, Options, and under Customize ribbon, you'll see an option for Developer. And if you select that, then the developer, so let's put one over here so you can see how to do it. The developer allows you to insert in this little slider button, so I can put one here. And then I can format that by left clicking on and it comes up with format. Then I can select the range, how much a change occurs when I move the slider, and which cell I'm linking it to. Well, I've done that already for volume, and I made two sliders just to make life a little easier. This slider changes the volume relatively quickly. This changes it in smaller steps. And so I can step through, for example, this way, and this are steps of 1 when I'm close to the value I'm interested in. So I put in a value of V of 30 just to demonstrate. Notice f of V is negative, and as I increase value of V with the slider, increments of 1, now it became positive. So somewhere below 42 is one of the solutions. And then I can take bigger steps, and this positive number is getting smaller. And again, I'm stepping slow, you can see what's happening. Notice it's now negative. So I went through a second solution. That's the one at 123. And then the other one, of course, is much higher value. So let's jump up. Since we know the answer, we can go in bigger steps. So right now we're at 11,800. It's negative, and as I keep stepping up, it's become small, but it's very slowly changing, but is indeed changing. If I keep doing this, it'll so notice it's very, very small, and then Now it's positive. So again, we pass through the third solution. This approach, particularly when you have one solution, can be a way to check, and we can move away the solution and make sure it's a good one. The third, of course, is, and let me demonstrate by putting back like a low value for volume, and that's to use solver. And here we see that what happens is interesting in that where we pick our starting point determines which solution we're going to approach. Well, in general, of course, if we are using solver, we don't know what the plot looks like. We don't necessarily know how many solutions. But if I put it in a value of 10 as my guess, and I go to data and solver, and I've already put in that it wants to change the volume to get this cell to a value of 0, and I push solve, you'll see it can't find a feasible solution. And indeed, between 1 and 25, I didn't try and get more detail than that. Any value I pick, it does not find a solution. If I pick a value of 30, and again use the solver, now it converges to the solution. It converges to the smallest volume, and indeed between 30 and 50 is my initial guess. It converges to that solution. If I now put in a guess of 55, and again use solver, it converges to the middle solution, 123. And so between 55 and 275 is my initial guess. It'll converge to that middle solution. Now if I put in a value of 280 as my initial guess, and let's just try one more time to use solver. Again, it converges, but now it converges to the high volume, 22,158. So clearly, and I can put values between 280 and 500,000 as my guess, and it'll converge to the 22,158 value. So it's important to point out that we have to be careful. Our initial guess affects whether we can get a solution and which solution we approach, and we have to keep that in mind when we're using solver. But all of these techniques allow us to solve a nonlinear equation relatively easily.